Counting. Here's what I'm going to tell you. This is called the fundamental principle of counting. It's also known as the multiplication rule for counting. Okay? So here's the idea. For example, does anybody recall, once upon a time, I used to think about this where I always wanted to know how many shirts and pants that I needed to own in order to wear the same, in order to wear a different thing every day for at least a week. I remember this in elementary school. Okay, you guys know what I'm talking about? A little self-conscious, I guess, when you ever notice some of these kids, they wear the same thing every day? Everybody notice that? Yes. I always used to wonder, do they wash their clothes? Do they? Not all the time. Okay. I was a little self-conscious about that as a kid. Now, that kid wasn't me, but those are some of my friends. Right? You guys know what I'm talking about? So I used to think about, okay, how many shirts and pants do you need that you wore something different every day of the week? So let's take a look at the situation. What if you had, 3 shirts and 2 pairs of pants? Can we determine the number of outfits that we can generate out of this scenario? The answer is yes, but we're going to draw a tree diagram to do this. You guys remember that tree diagram? Let's start with our shirt, right? Shirt 1, shirt 2, shirt 3, meaning that I have 3 options for my shirts. You guys okay with this? 3 options. And then for each shirt, how many options do I have for my pants? 2, is that right? So if I use shirt 1, I could use pant 1, or I can use pant 2. You guys with me on that? If I use shirt 2, I can use pant 1, or I can use pant what? 2. If I use shirt 3, I can use pant 1 or pant 2. This is a tree diagram of the number of outfits. Now, when you follow the branches, what do you guys notice? Shirt 1, pant 1. Shirt 1, pant what? 2. This is one outfit. This is the second outfit. The first outfit has shirt 1. Second outfit has shirt 1. So the first 2 outfits, they share the same shirt. They just have different pants. The second set here is shirt 2, pant 1, and shirt 2, pant 2. The third set is shirt 3, pant 1, and shirt 3, pant what? 2. So if I look at all of these things, follow the branches, I determine how many different outfits are possible. There's 6 outfits. Okay, you guys okay with that? The answer is 6. Well, here's where the fundamental principle of counting, or the counting principle, comes in. Here's a principle. If task 1 is done in n ways, task 2 is done or completed in m ways, then the tasks together are done in n times m distinct ways. So what you guys have seen here really via a tree diagram is that, if you notice, there are 1, 2, what? There are 3 choices for shirts here, 3 shirt options, and then there's how many pant options? How many pant options are there? How many options of pants do you have? 2. So then what is 2 times 3? Isn't that 6? So here's what's happening. Instead of having to draw a tree diagram to count, instead of doing that, what could you guys use? The counting principle, or the fundamental principle of counting, also known as the multiplication rule for counting. Why do you think they call it the multiplication rule? Because what do? You multiply. Good. And here's a fact. This process can be generalized. What do you think that means? What did that mean last week when I gave you that multiplication rule? Do you guys know? It means you're not limited to only 2 tasks. It could be any number of tasks. Just like the probabilities of selecting items, you're not limited to only 2. You could select 3, select 5, 10, 20, 100. This is generalized. So for example, where are the shoppers? Who likes to shop? Where are the shoppers here? Okay. You like to shop? Okay. How many blouses do you have? Let's hear it. Go ahead. 100 blouses. Blouses. How many pairs of pants do you have? 58 pants. How many shoes do you have? Pairs of shoes. Huh? Yeah, how many? 20 pairs of what? Shoes? Huh? All of them. Huh? How many? You got 50 pairs of shoes? Is it safe to call her a shopper? How many purses do you own? How many? Claudia, how many purses do you own? All right, how many purses do you own? 15 purses, okay. Do you own any hats? You wear any hats? How many sweaters? Mm-hmm. 4 sweaters? So you don't like to be warm, you just like to look good, right? Sweaters, 4 sweaters, okay. Fine. So let's ask this question. An illustration of the generalization of the process, the multiplication rule here. You guys know an outfit now consists of these items. Is that true? In other words, 100 blouses times what? 58 pairs of pants times 50 shoes times 15 purses to go with her 4 sweaters. How many outfits are possible under this scenario? 300 and what? 48,000? Is that it? 348,000. So there's 348,000 different outfits. Okay? 348,000 different outfits. You guys want to know how many days of the year are there? How many days are in a year? 365 days is 1 year, right? Can you guys divide that number by 365? 348,000. What do you guys get? Yes, yes. Got a different answer? What did you guys get? 17,400,000? $17,400,000 different outfits, right? Okay. Divide this number by 365. What do you get?